Hey everyone. Okay, another day, another Leetcode problem. So today we're going to be looking at 1391. Check if there's a valid path in a grid. Okay, I'm just going to go ahead and directly start explaining this problem on my iPad. I think it's better for me to draw here. All right, so the problem states that we are given an m into n grid, and each cell of our grid corresponds to one of these values between 1 and 6. So what exactly these values mean, they correspond to a certain street, the path that a street follows. And if we see in the problem, this is the same thing. I've just kind of drawn it out here. Okay, so before we actually go to one of these questions, examples here, I want to get some information here so that we can keep that handy. That'll help us solve the problem later on. We can maybe keep that as a key for reference. So yeah, if we look at the street, the path that these streets are following, I can see that every street is the combination of like two different positions. Like street 1, you could say that it's going from left to right. And for street 2, I could say that it's going from like top to bottom. So I see that yeah, even like street 3, it's going from left and then down. So at max, I see that it's a combination of two different directions, and I don't see diagonals anywhere. So I can easily I can conclude that these are our basic 4 directions: top, down, and left and right. So we don't need to have diagonals. So let's just keep this ready. See how we're gonna map things out. So let's say I start from this position. Let's say this is at our 0, 0 coordinate. And if I want to go up from here, obviously what I'm doing is I'm reducing my row and my column is staying the same. So I could do a -1 on my row and my column basically remains the same. And now if I want to go down, I see that I'm increasing my row and my column is remaining the same. And if I want to go left, I see that I'm decreasing a column, staying in the same row, and actually decreasing a column. And if I want to go right, then I see that I'm staying in the same row and actually increasing my column. Okay, so we'll have this handy. And as we can see, using these 4 directions, we're actually able to map these streets out in the form of these basic directions. So if I look at street 1, I see that it's going from left to right. And street 2, it's going up and down. Street 3 is going from left to down. And street 4 is going from right or down, either of these directions. That's where it leads to. And this is left and up. And street 6 is giving us a right and up. Okay. All right, so this is going to help us going forward. Now let's go to one of these examples. So what they're asking us for is that we have to start from our position, that's 0, 0, and we have to go to our m-1, n-1 last position. So here it's 2, 2. We'll write the index values. This is better. Okay, I have to go here, and I have to check if these paths are actually valid, and they're going to take me there, or if they're going out of bounds and all those conditions. So this is a basic grid graph traversal problem here, and for this, we can go for a DFS or a BFS, but I am going to prefer going for a BFS. So yeah, let's kind of go through an example and see here. So the intuition here is that if I want something to be a valid path, it means that obviously if I'm going somewhere, I should be able to come back to where I was. And that would mean that the path, like it's actually valid. So in this condition, like I see over here, I'm starting from my cell 0, 0, and I'm going rightward or left. Left is out of bounds, so let's consider right. And when I go to the second position, it's like I go somewhere and then I see that there's no road there because this road is going from up and down and it doesn't connect anywhere. So this is invalid, and I would stop looking for a solution because I know if I don't have a road that's connecting me, then there's no way that I could go to my destination. But in this case over here, I see that I'm going from my first cell, I'm going down, and my second cell, which is over here at the bottom, it's actually able to go back to the cell that it came from. So I know that it's valid. And yeah, we go on doing that until we reach the last cell. So as I mentioned that we're gonna use a BFS approach over here, let's go ahead and just see how that's gonna work. So one thing is when we're doing these traversals, we wanna make sure that we don't go back to a cell that we've already visited because we might end up in a loop if we do that. So I wanna have like a visited set over here. And since I'm starting from my 0, 0 position, I can just add that there. I want to have a queue because for BFS, so 0, 0 is my starting coordinate. Okay, so the first thing we're going to do, maybe I'll choose a different color. Yeah, okay. So the first thing we're going to do is we start from this position here. We're going to pop that value, 0, 0. Okay, so that is telling me the exact location where I will find my path. And it's this one over here, right? Maybe red was better. So if I see 0, 0, I see in the grid 0, 0 corresponds to the path 2. And if I look at the path 2, it tells me that from path 2, what I'm connecting is the up and down locations. All right. So I can either go up or I can go down. And so what we have now is our R and C values are 0 and 0. And from that position, I can either go up or down, and up corresponds to -1, 0, and down corresponds to 1 and 0. I mean, just looking at the problem, I know that if I go up, it's out of bounds, so I'm not going to consider that. Let's look at the value for down. So for down, it's 1 and 0. So if I add the coordinates to go down, I end up with I end up with the coordinates 1 and 0. So if I look in my grid at the position 1 and 0, it's a 6. So if I go to that location, I want to see how is the road aligned there. So the road alignment would be our street map. If I go to 6, it says I can go right and up. So the thing I'm doing here is I started from this position and I went down. I went down and there's a road there. So if I came from the path of coming down, I need to know if that road is connecting back up. Okay, so I went down and I need to see if the value of up is in the road's alignment over there. So I look at the road's alignment, and it's right and up. So yes, up is the opposite of down. So it means that I do have a valid path, and this works out. So it means that from 0, 0 coordinate, I was able to go to 1, 0, and that was a valid path. So now I've also visited 1 and 0, and in my queue, I'm going to be adding 1 and 0 over here. Okay, so the next value that I'm going to pop is 1, 0. So my R and C is going to be equal to 1 and 0. And let's look at 1 and 0. It's 6 over here. So 6 had, it was able to go right and up. And now if I look for up, I know that it's already invisited because that's 0, 0. So I can't go up. So let's see what happens if I go right. So if I want to go right, I have to add 0 and 1 to this. So if I add 0 and 1 coordinates, then I'm going to get 1 and 1. So it's going to lead me to position 1, 1, which is over here. And if I look at the same thing in our grid, that leads me to a road alignment of 5. And a road alignment of 5 basically connects the left and the up areas. So I can see that I took a rightward path to go there. So I want to see if that cell connects back to a leftward path. And if I look in 5, yes, it does. It can go back left. So I know that this is a valid position that I can go to. And I want to go ahead and add that to my queue, 1, 1. And that's also in my visited as 1, 1. Okay. So now let's pop this out. And we have R and C is equal to 1 and 1 here. And let's go to 1 and 1. It's a 5, as we saw earlier. That connects to left and up. Again, I'm not going to go left because that's already visited, but I can go up. So if I add the coordinates for up, it's so 1 again, I'm going to be subtracting 1. So that's going to be a 0. And then 1 plus 0 is going to be a 1. So it takes me to the position of 0, 1, which is over here. And let's look at how the road is aligned there. So 0, 1 over here, it corresponds to 4. So let's see how the road is aligned at 4. It connects right and down. And the path that I took to go there was actually up. So if I go up, then I want to make sure that it goes down. And if I look at this, it has right and down. Down is present in this. So yes, this is also valid. And I can go ahead and add this to my queue. This is a place that I can visit. And this is a place I was already visited. So 0 and 1. Okay. Now, again, let's pop from this. We go to this position, 0 and 1. We have a 4. I think you guys are understanding this, but I'm just going to go ahead and still explain it in case you want to see it till the end. So we go to 4, right and down. I don't want to go down because already visited. So I'll go to the right. And let's see, I had a position of 0, 1, plus the right coordinates is 0, 1 again. So that's going to take me to a 0, 2 coordinate. And 0, 2 is this one, which is 3. And if I look at 3, it has a left and down. So I went right, so I have to be able to come back left. And as I see, left is present in that road's alignment. So yes, this is correct. I'll go ahead and add, what was it? It was a 0, 2. And 0, 2 is also possible to be visited. I'm sorry, I'm running out of space here. We can rub some of this stuff off. Yeah. Okay. Yeah, so we're able to come to this location, which is 0, 2. Okay, so now let's check at 0, 2. This corresponds to 3, right? 3 is left and down. Left, I don't want to go. I've already visited. I can go down, though. So down corresponds to 1 plus 0. So this is going to take me to, it's going to take me to the location 1, comma 2. 1, comma 2 is this one over here. Okay, and 1, comma 2 has a road alignment of 2, which is up and down. Okay, so I took the path of downward to go there, and I see that in that path, I can go back up, which is correct. So again, I had popped this right. So I'm going to go ahead and add 1, comma 2 over here. I'm sorry, this was wrong. This was actually in location 1, comma 2. Okay. So once I add that, again, this is the last value in my queue. I'm going to pop 1, comma 2, and then I kind of check. So it is the location that I was trying to reach, right? It's m minus 1, n minus 1, because m value is 2 here, m minus 1 is 1. 1, comma 2 is the end location that I'm trying to reach. And I was able to reach it, so this is a valid, it's a valid grid. It has a valid path from the starting to the end destination position. Now, as I mentioned again, from this position, this grid, if I check, once I go from here, I can go from left to right. And once I go to the right position, which would be 0, comma 0 plus, what is it for right? It's 0, comma 1. I'm going to get 0, comma 1. And I go to this, which corresponds to 2. And 2 connects up and down. And I took a rightward path to go there. Up and down does not have the value left back in it. So no, this does not work out. Yeah, I hope this explanation was good enough to understand. We can just go and check the code because I've done basically the same thing. I have my directions here. I'm mapping this out to those streets and the alignment of the directions they're following. I'm just using a reverse here because like I was mentioning, if I go right, I need to come back left and all of that. So I've just mapped up, down, up, left, right, left. And we, again, have our queue. We have a visited set. So here we're popping from the queue. We're just checking, is this my final position? If it is, I just return it true. Or else we're going to check for the directions within that street, like wherever it was leading to. So it would be either this left or right. So if I take left, then I would be taking the coordinates of left again. And it's the same thing we were doing. And I'm going to check. If it's out of bounds, I just want to continue. I don't want to use that. And we've popped it out already, so that's fine. And then we want to check if the neighbor, so the reverse of that, if it's connecting back. So in the street map, if that neighbor is the path that it took to come there is the reverse of that path actually possible. So we're checking that, then we're going to add it to our visited, add it to our queue, everything the same stuff that we were doing. So yeah, this actually works. We can go ahead and check the time complexity. So all of these, this is just O of 1, we're not doing any calculation. And I'm going to say the space for this is also O of 1 because we have a fixed number of stuff. So now the queue. So the queue is, yeah, this is where we actually consume some space. At maximum, see, we're using a visited set, so we're not going to be adding the same cells again and again. At max, this can take a space of the number of cells we actually have. So that's m into n, and it would be the same for visited as well. So yeah, we can go ahead and put that. So now the time complexity. So really, if we really look at this, what are we doing? We're going to each one of these cells. So that's, again, it's an O of m into n. And for each cell at max, we're looking at, for in the street map, right? If we look at street map, it just has basically two different directions it can go to. So that's constant time. So if we look at what happens here in our BFS, the time would actually be O of m into n into 2, but the 2 is negligible. So yeah, this is O of m into n, and our space is also O of m into n. So let's just go ahead and write that over here. Time is m into n. Space is also O of m into n. Actually, it's 2 times m into n, but we're going to remove constants since we're using 2 of these. But without constants, it's m into n. So yeah, let's go ahead, submit it to see, and it's working fine. So I hope you guys understood this explanation, and yeah, happy coding.